Hello, my name is Apollonio Romero, and I will be discussing about the philosopher's dining problem, as well as running the code in C language ran in Ubuntu. Now let's get started. First off, what is the philosopher's dining problem? Here, there are five philosophers on the table, five philosophers. And there are plates of food on the table that can only be eaten with two forks. These forks are placed between each plate, adding up to 5. Now, there are conditions to this problem. First, a philosopher must think until the left fork is available and the right fork is available. When they must pick it up. And then when both forks are held, they must eat for a fixed amount of time. And then put the both they put both forks down in the order of left and right, same at the same order as when they pick it up, and then repeat from the beginning. Now, what this problem want to find is how to do this in a concurrent way simultaneously, because if it's done in a true simultaneous way, each philosopher would take the left fork and then they would forever stare at the right side and starve to death. Now, for this problem, we'll do a visual model. It would look like this. We have the 5 philosophers, the 5 food, 5 plates, and the 5 forks. Now, to solve this problem, we're gonna do first a pseudocode to outline what we should do for this code. Process is 5 while true to philosopher is hungry. If the philosopher on its left and the philosopher on its right is not eating, then take the fork on the left and on the philosopher's right. And then the philosopher would start eating for a few seconds, and then they would put the fork on the left and the fork on the right down. And then the philosopher would think. And then this process would continue on and on and on perpetually. Now, this is basically the pseudocode. And then I'm going to show you a code for this philosopher's dining problem. So this is the code. First, we include 3 libraries, which is Feedthread, Semaphore, and Studio, and then define constants, which is n is equals to 5, thinking is equals to 2, hungry is 1, eating is 0, left is to the left of the current philosopher, and right is the right of the current philosopher. Then we have 2 variables, which is 2 arrays. The first array, state array, is empty, but it has 5 indexes in it. And the fill array also has 5 indexes, but it's filled with 0, 1, 2, 3, 4, which is the same as the indexes they're in. And then we have the semaphore mutex, and in the semaphore that is also an array, which is 5 arrays. Oh no, not 5 arrays, but 5 indexes. So that would equate to 5 semaphores. Next, we have 5 functions, which is test, take fork, put fork, philosopher, and then main. We're going to go through all those functions according to the order they are called. First, we have the main function. Create the variable and then create the general threads, which is equals to 5 here, n is equals to 5. And then initialize the semaphores. First, we initialize mutex as semaphore, and then with the for loop, initialize the 5 semaphores here. Then for this next code block, for this for loop, this is where the actual code, this is where the actual program will start. Here we have the feed thread create, which assigns a thread to a philosopher, and every time the thread is assigned to a philosopher, the function philosopher is then called, which is here. Now, because of this, the while loop makes it infinite. Therefore, as long as the program runs, this will not terminate. So first we have this, which is basically this the number of the current philosopher, as you can see here, the for loop condition here. It is then given here as the num is equals to I, and then take fork function. The sleep is basically waiting for 1 second before doing the next function. The next function is take fork, which is the current philosopher's number is then taken to take fork function, which becomes the cur ph. While doing this function, we use a semaphore for this, which is mutex, and lock it up so no other thread could use it anymore. And then we're going to turn the state of the current ph, the current philosopher, into hungry. So it's now if the current philosopher is 0, and then the index 0 state is 1, because the state is hungry here. So it's the same for the others if the other philosophers are also called this way. Then print the philosopher is hungry. This part is appended here, so the current number of the philosopher plus 1, because you can see here current number would be 0, 1, 2, 3, 4. No, it's actually no, this is not it. This is the array. What is giving is the cur ph, which means it would be this one here, the I. So it would be 0, 1, 2, 3, 4. And since we refer to them as philosophers 1, 2, 3, 4, 5, it was necessary to add the plus 1 here to that. Instead of the philosopher 0, it becomes philosopher 1. Yeah. And then we do the test function. And then we give the value of cur ph into the test function. In this code block, it states that if the current philosopher is hungry and the left and right philosophers are not eating, then it changes the state of the current philosopher into eating, and then sleep for 2 seconds or wait for 2 seconds, and then prints the current philosopher takes the fork of the left philosopher and their own fork, as appended by here, and then prints out the current philosopher is eating. As you can see here, there's a note here. Sem post this, which is basically this semaphore, has no effect during take fork. Simple because if you look at the take fork function here, remember the sem wait, and then the semaphore mutex. We didn't declare a line like that before the test function, so this is basically useless because there was no semaphore to release. This line is used to release a semaphore or unlock them. Once that function is done, this function continues again, and then that's where the mutex semaphore would be unlocked, and the semaphore of that current philosopher would be locked. It says if the note if unable to eat, wait to be signaled. That basically means that because inevitably one of the philosophers will be able to take this function first, this whole region, this whole block of code here will be inaccessible by any other philosophers. Therefore, it has this. Of course, the current philosopher that run this will also have this. Will lock the semaphore themselves because they're eating. Once they once they've eaten, it does the foot fork function, which is here. Again, it uses the mutex semaphore and locks it, and then it changes the state of the current philosopher to thinking. It then prints philosopher. The current philosopher is putting the fork of the left philosopher down and its own fork, and the current philosopher's own fork, and then the current philosopher is thinking, and then it tests left and right. So the left and right philosophers. In here, we basically wake them up, but not in a traditional way, because in the if you recall correctly, in the F condition here, as long as the left and right philosopher of the current philosopher is not eating, therefore as long as they're hungry or thinking, then this entire block of code would still run. So because of this, after the take of forks, it allows this function to basically used to wake up hungry philosophers during foot fork. Because as you remember, once at the take of fork function, their semaphores are locked, and using this, it unlocks the semaphores. After it unlocks the semaphores that were hungry. Here, see? Here. Now the left, that's for the left and the right philosopher of the current philosopher. And then, after the function was done, it unlocks the mutex semaphore, which means the next thread or the next philosopher to use it will be able to use it now. Because of this, the format of this code here, because it's a while loop, this entire steps calling of functions, put fork, take fork, and test, will perpetually happen until an error happens. But since it's a perpetual program, an error will never happen, or unless you terminate the program. So that's it. And this one here, this is after each thread was created. So once the thread is created, it does this, and then it prints this philosopher, the current philosopher is thinking, and then it does the philosopher function. And for the last code block, block of code, we have pthread join, and then the general threads that each semaphore has. This basically means that after the semaphore is done, or the thread is terminated, the process is terminated, then any resources that it used will be reallocated or reclaimed, so that the other threads could use it themselves as well. So that's basically the entirety of the code. It is kind of complex because we have to consider the states of the philosophers and the current states of the philosophers of left and right. As you could see, we could think of this as philosophers having each one fork. So there's 5 forks, so Even if you say that if you the right and left fork, you're basically saying it's basically saying the current philosopher's fork and the fork of the left. Now that we explained the code, it is time to actually run it. And if you look here, I already compiled it here. This is this is what we're going to run in the terminal. So go here and get the terminal. Now, first we'll go to the directory of the file we're going to run. So that's documents and then Philodyne. And then we're gonna do this. We're going to run that. And as you can see, the output is doing its work. Right? We're going to run it a little bit more and then we're going to explain what's happening. Alright. So here it is. So let's go first at the first iteration. We have 5 takes fork of 4 and then its own 1. Then 5 is eating, 5 is putting fork 4, 5 down, 5 is thinking. Now, this does not mean there was something wrong with this. This is basically so you could think of this as initializing. Because after all, this is a concurrent process. So there would be a lot of threads using this. After that, then it starts to do the random allocation. We have 4, 1, 4 is take the fork, 1 takes the fork. Because 1 takes the fork, 3 and 5 can't take the forks anymore because they're using it. And then 4 bring down, 3 is available. So now 3 takes the fork of 2 and its own fork. It's like that. Basically, in every thread, if every philosopher, if the right side and the left side is free, then they're going to take the fork. As long as those two are free, they're going to initiate the process. So that's it. That's the code. It's not the code. I'm pretty sure there would be other codes that could simulate the same program for this philosopher's dining problem. But for now, this is a code that would go through like this. I'm sure there would be a more complicated code for this, but I don't know enough. I don't know enough to create the code like that. So that's a code for philosopher's dining problem, and thank you.